Okay, hi everyone. This is going to be a talk of operating a Windows platform at scale in the cloud. It's going to be a reasonably high-level talk. I'm going to wave my hands a bit. You can ask me at any point to go into more detail, and I'll do that. In fact, I'd prefer if you interrupt me with any questions. Just stick your hand up, and we'll pause and answer questions like that. So, I'm Peter Mounce, or Pete. I'm ex-Just Eat. I worked at Just Eat between 2010 and 2016. Just Eat do online takeaway. And while I was there, I worked in a number of teams. So I was a generalist initially when we didn't really have teams. I worked on a lot of systems automation, so build and deploy and test, and infrastructure once we had infrastructure. For a while there, if you bought food with Just Eat, then you were paying for it through code that I wrote, which is terrifying. I was involved in slicing apart the monolithic website into a set of APIs, both internal and external. I was working on the project to migrate the Just Eat platform from the data center that existed at the time, may it rest in peace, to the AWS cloud and introducing the notion of infrastructure as code. And from about 2012 onwards, I operated the code that I worked on, that I shipped to production. Since then, since July, I started work at Improbable, where I make about 70 engineers ship faster. I'm an engineering effectiveness person there. The engineering effectiveness person there. And I guess you can think of me as a plumber. I remove gunk from the continuous delivery pipelines that don't quite exist yet, but we're making them better all the time. As I said earlier, if you have any questions, please ask them as we go. I'd really rather address anything that isn't quite clear as and when it comes up. I get the most use out of conference talks like this when I interrupt, so please do the same. So my contention and my experience is that it's possible to do DevOps on Windows at scale in the cloud and not have an absolutely terrible time. So that's it, right? Talk done. No, there's a bit more detail. What do I mean by that? So I mean continuously delivering software that's valuable. Software that adds valuable, so hopefully the right software, the right changes, not just software for the sake of it. I mean a platform that you can scale horizontally by just adding servers to it, and the capacity will increase linearly. I mean a system that you increase resiliency in by removing single points of failure, so that failure is something that you embrace as you go along and you just deal with in a degraded state and you recover from. And also elastic. So it's the 21st century. You should only be paying for the compute that you need, not to have it on all of the time when you're in an ebb period of your system's demand cycle. So how out of date am I since leaving a Windows platform? That's one thing that Improbable don't do, is a Windows platform. But happily, Just Eat did. So sometime earlier this year, .NET Core shipped. So apparently, a modern command line first toolchain that you can run repeatable tasks with. And apparently dependency management that works better than before. Haven't used it, don't know. And also last month, Windows 2016 Server finally shipped. And I guess one of the flagship features here is Nano Server, which is a server that is almost exactly like Linux, that doesn't have a GUI. So it's got a much smaller footprint. And so rather than a 20 gig minimum install, it's a couple of gig minimum install. Apparently you can run native SSH on this, although I hear that's still a bit of a work in progress. And you can finally containerize Windows applications as opposed to simply run Docker on Windows to host Linux-based applications. So this is really cool. So I'll introduce Just Eat a bit. Basically, online takeaway. Do you use? I guess Just Eat don't really operate in the Ukraine. Are you aware of what it is in general? Takeaways at the end of your street. They want your business. They give Just Eat menus, and you, the customer, order the food on the Just Eat website. Just Eat tell the restaurant about the order, and the restaurant goes, "Yeah, excellent, extra business. I'll ship you your food." That's the idea. So, started in Denmark in 2001. Started in the UK in 2005. I think it's now in about 14 different countries. And to give you an idea of scale, in the biggest country, the UK, it's about 70 searches per second at the head of the funnel, about 1,000 orders per minute at peak time at the tip of the funnel, or there's probably more now. Fake load in peak time in production adds another 50% to that figure, so another 500 orders a minute. Again, probably figures are out of date. The platform is hosted entirely in AWS as a cloud-native, all-in, not abstracting anything away. So it's baked into AWS. And the servers, they don't scale reactive to load, but they scale on a schedule. So imagine for a moment, well, we Just Eat cheats, really. It knows exactly when people start to become hungry because it's when everyone starts to become hungry. It's sort of you're leaving work. Do you fancy a takeaway? Yes? Excellent. Just Eat. And that's roughly what happens. The cliff is like that, not a gradual curve. So it's really easy to scale up the server capacity at about 4 o'clock ahead of the 5 o'clock demand. Losing a server is not an interesting event, except maybe when I do it too much on stage. That was a favorite demo. And to give you an idea of the pace of delivery, in 2010 when I joined, we did maybe 10 or 20 production changes. I won't call them deployments because they were literally week-long, drawn-out efforts of how do we ship this software we've just been building, to about 1,000 deployments in 2014 when we finally figured out that we don't need to count this anymore. We've ticked this box. I guess the main thing of operating at scale, whether it's a Windows platform or anything else, is you want to be able to treat your servers like cattle, not like pets. You might have heard the phrase. It's the notion that you care about a pet. You give pets names. You take them to the vet when they're ill and you get them to be healthy again. It's an event when one dies. With a cattle, you shoot it in the head. So really, when you treat your servers this way, if a server dies, when a server dies, you want a computer to make a new one for you without being interrupted. You don't want to be in that loop, because in the cloud that will happen often. In a data center it'll happen less often, probably, except at the worst possible time. So for this to work, you really need deployment automation as kind of table stakes to get into the game. The act of unzipping a package and putting a compiled piece of code onto a server should really not be something a human is involved in. It should be the same every time, maybe parameterized depending on environments. Also, you kind of need a clean server image that has the stuff that you need present to be. Well, you need to have one of those, a golden image. And at this point, happily, in the Windows world, creating a golden image is a reasonably solved problem. At Just Eat, they use a thing called Packer, which is a tool from HashiCorp. And essentially, it's a build script, but for a server. So you start with a clean OS install, and you run some commands to, download the latest .NET framework that you need, download and install antivirus, download and install stuff, and then bake that as a server image. And then that's what you start from when you want to do a deployment of a new server. So that set of steps is captured in source control, just like build automation. So it's now very constrained. You know exactly what a server will come up with when you boot a server. You don't have to rely on that bloke in operations or that person in operations following a wiki page that was up to date 3 months ago that's changed since, and he's remembering the 3 months ago version. That doesn't happen with this. It's also really advantageous to apply this to your pipeline infrastructure as well as your production infrastructure. The pipeline infrastructure is how you get from editor window to production. It's your source control, your continuous integration, it's your build agents. If that stuff is buildable repeatably, then you're in a much better place because you can change your dependencies that much easier. So here I'm going to go into a sort of potted history of scaling at Just Eat, and scaling in terms of people, scaling in terms of the platform. In 2010, I guess we didn't really know what we were doing. I joined in 2010, and I didn't know what I was doing. We had a data center in Denmark, I think. Nobody's really quite sure. Only a couple people really know. And the technology team was kind of rebooted in the UK. And so there was a lot of knowledge sharing that needed to happen really quickly, which probably could have gone better. We had about 5 to 10 developers over the course of 2010. We had a couple of mostly manual QA testers, and we had a few systems administrators. And we didn't know things like how to build the software. There are about a dozen different components of the running platform per country. There were 7 running countries. And we didn't know which workstation was the blessed one that could create the build of the website. And then when we went to deploy it, we didn't know which servers to put it on, or where on those servers to put it, or how to configure IIS if we ever needed to configure IIS differently, because IIS 6 back then defied being automated. And yeah, we didn't know how to test that you could order food on the internet, and that was kind of the core business proposition of the team. We didn't have any QA environments. We certainly couldn't build another one just by running some script. We didn't have any credit cards that the company owned to test with, so we got a lot of expensed free food. We couldn't build new servers because it wasn't written down how to build new servers, and all of the existing servers were different, so we didn't know which one to try and copy. And I guess we also didn't know who to talk to in the business to find out what to do. Really, there were 9 businesses. There were the 7 countries that were operational at the time. There was the exec team, and then there was the product management team. And so, well, getting the different people to agree what they wanted and how they wanted it and when they wanted it was a challenge all by itself. So yeah, 2010 was a tricky year. In 2012, as a reaction of, I guess, quite a lot of problems in production that were seen as being avoidable if only we could monitor production and see what was going on in production. In the first hackathon, I built a statsd and graphite server, and it was about as ropey as it was possible to do in 2012 for somebody who'd never really used Linux in production. And it was basically, I found a bash script online that launched an EC2 box and installed statsd and installed graphite on it and went, yeah, graphite, we can see a chart. And then I spent the next day and a half figuring out how to publish a stat in UDP over UDP, which is essentially a string to fire down a UDP socket with a number on the end. That's the easy bit. But actually finding out where to put that publishing in our code base to instrument the bit that I wanted, that was quite hard. But at the end of the hackathon, we did have a chart that would tick every time the order processing loop completed. And so we'd be able to see when it got further apart or closer together. Yay. This doesn't seem like much, but compared to Performance Monitor and performance counters in Windows, if you cast your mind back to 2012, you'd log on to a computer and open up perfmon, and maybe you'd saved the set that you had last time to have a look at, and you'd go to each server and look at them, and that's efficient. No, it's not really efficient. So yeah, amazing. That was actually a step change in our operational clue, because now the developers would get told when the operators rolled back a thing when the operator said this caused CPU spikes, and the developers previously would be able to say, oh, it could have been anything, and now the operators can go, well, we deployed here, and the CPU went like that, and we think it's you, and the developer would go, oh yeah, okay, that probably correlates quite closely. In 2012, developers start to be on call for the code they ship. This is revolutionary. So, as well as that quote, which I like, it's also true that your system gets more reliable if you put the managers on call too. If you put the people that are making the priorities of what to work on call to have their personal time interrupted, then they're going to feel the impact of their decisions and possibly adjust those decisions according to whether they're having a good time or not. But yeah, fundamentally, if the people that are shipping code are also on call for it, then they're going to invest more time in having things like good logging, good monitoring, good insight into production, good debuggability, good engineering. Whereas previously they may try to cut those corners to hit deadlines. Now they will actually push back, and with good reason, because otherwise they will burn out. In 2013, we shipped AWS, or we shipped into AWS, I should say. It took about 6 months of about 4 people, myself included, to figure out how to do this. We learned things like EC2 and virtual private clouds and networking. That was awesome. And how to bootstrap instances inside of AWS with CloudFormation, how to define stacks in CloudFormation. So essentially, CloudFormation is a piece of configuration management software that AWS give you to ask for resources from AWS, and AWS receive the template and go, yep, here you are, 20 minutes later. In the quarter that we shipped into AWS, we actually had the highest recorded uptime of our system to date. So that was a success. We elected to go all in with AWS. So we didn't really wrap the services that we used. We're just using them barely, nakedly. Maybe is a better word than just barely using them. And mostly at this point, we were using infrastructure as a service. Although that, the EC2, the networking, the CloudFormation config management, S3 for file storage. Later on, we would start to use things like DynamoDB, the simple queuing service, the simple notification service. It became an easier thing to say which services we weren't using at Just Eat than the ones that we were. So, yeah, we didn't waste any effort on trying to hide away the details of the cloud just in case we decided to change our cloud later, because, well, we're still in AWS, it's still having a good time. Remember, at the time also, Azure was not the Azure of today. If the decision to migrate came today, then it would be a much more interesting discussion on which cloud to choose. Also, migrating to the cloud forced us to address some of the engineering debt that can easily build up when you're in a data center and the database server is on the same rack as the web servers, and latency is non-existent. Now, latency exists. You can't rely on things like file shares on the web servers being available to the others. You don't have fixed IPs probably. So now you can't keep state on the servers. You can't keep data on the servers because your servers will die regularly in the cloud, because we'll force them to die regularly to force the issue of addressing the technical debt. So that was a bunch of work, but also put us in a very good position to accelerate later. It forced us to address deploying servers well. So a server bootstraps by itself. There is no person doing that. In 2014, again by hackathon, we introduced another operational tool. This was another step change in how we operated well. The Elasticsearch, Logstash, and Kibana trio is kind of the standard thing to use here, or at least as far as I know. Logstash is a thing that receives your logs and then stashes them in Elasticsearch. It can also do things like enrich them on the way through. So for example, if you have an IP address, it could do a geo-IP lookup to attach to the log message the lat and long of that IP address. So it can enrich that data in Elasticsearch so you can do more interesting queries. Until we had this, we had a scheduled task that would run every 10 minutes and upload all of the log files on a server to S3. We realized at one point that was the reason we were taking down our NAT instance, because we're uploading all of the log files on all of the servers rather than just the new log files on the new servers every 10 minutes. That was a single character to fix, but a couple of months to find. There's lots of learning that we did with Elasticsearch. It has a few gotchas, like the JVM heap size, I think. I'm not an expert here, but the JVM heap size, what the JVM is to a .NET shop, how many how many servers to put in a cluster, the distribution of master nodes versus slave nodes, what a master node is and what a slave node is, that sort of thing. But at this point, that's very well documented and blogged about, so it's much easier than it was to get started. And essentially what this is allowing you to do is debug in production with printf. So it turns out that rather than hooking a debugger on, having your application tell you about what it's doing is really useful, because in production, probably you can't attach to a running process with a debugger. Either there's a firewall in the way, or you're explicitly told not to, because now all of the processes that hit that server attach to your breakpoint, and that's bad. And essentially, yes, if you're trying to debug your thing, log statements are usually a more realistic choice. It also encourages people to write better logs, which allows more people to be able to help with the problem. Alerts. Oh, I love alerts. They're just tests that run every 30 seconds in production. They test that a threshold hasn't been breached, basically, or a threshold over time. So we always had alerts, since we had statsd and graphite, because we didn't want to stare at dashboards all day. But they were, well, who here has continuous integration? Raise your hands. And how many of you have test automation that run in continuous automation? Great. And so how many of you have flaky tests sometimes? A lot fewer of you, but sort of half height hands. So yeah, us too. And an alert that fires in production that then immediately resets itself, that's really a flaky test. So what do you do when you have a flaky test? Do you ignore it? Yes, that's exactly what we did too. So we had this alerting server that would look at graphite and fire off these alerts, and some of them would flake, and we'd ignore them and we'd disable them, and we wouldn't make them better, which is what we were supposed to be doing. And what every responsible engineer should be doing is making the software better by improving the test automation that proves that it's better. And what would happen is that the system would get more broken over time, just like if you ignore flaky tests. So what we did in 2015, I wish I'd had the idea, it's a brilliant one, was we put the alerts in source control. And then every morning at 9 a.m., we blew away the server and replaced it with a server that had all of the alerts set up as they were in source control. So now you could turn off an alert if you're having a particularly bad evening and you know something is broken, but the alert will just keep firing and annoying you, but fix it the next day, because the alert will come back. Structured logs. So we realized, as I said, that logs are important. And because we didn't really have anywhere to read the logs in a particularly nice way, people didn't read the logs, so any old crap would get into the logs. I'm sorry for the horizontal scroll here. There's nothing particularly funny there. And so every time you put data into a log, a person who reads the log goes and creates a regular expression to parse that data out of the log if they care. And very soon, they either run out of time to care, or they stop writing the regexes, or the regexes break because you changed the string, right? It's just a string. And that tends to go badly. So we realized that that's a terrible idea. And so we realized that just like you have contracts for your applications, it's probably quite a good idea to have contracts for your logs. And so we created one. So now, insteed of a person writing a ridiculous Elasticsearch query that has regexes that performs terribly because it has regexes and it's impossible to read because it has regexes, now you just do JSON.parse, or the thing harvesting the event does JSON.parse thing, Elasticsearch, thank you very much, that's a document right there, and everyone is much happier, and we can create dashboards based on good data and alerts based on good data. So we created a thing, we open sourced it. It's called nlog.structuredJSON, I think, because nlog was our log library of choice. And now most applications use that to write logs, and therefore all of the logs have a set of standard fields: timestamp, level, application name, application version, line number. There's a stack trace if there's an error, and it's a stack trace as an array of strings rather than just one long string. There's a hash of the stack trace, so you can do things like bucket up the errors, so you can see when new ones happen. And it's a much better world to live in, and it's a very cheap thing to do in terms of your code base. And you end up then having log statements that say that you can actually uniquely identify, because the string now doesn't have any data in it. And so you know probably where that came from if you're operating the code that you saw the log from. So, talk about deployment for a while. We spend a lot of time in talks like this talking about deploying things. It turns out there is a finite number of ways, but it's large, to deploy a Windows website or a service, and I'm pretty sure we tried all of them. We had people initially, following wiki pages or fiction. We had batch files. They stopped being used. We had VB script in a particularly dark time. We introduced Ruby, because well, why not? We're a Windows environment. Why would you not introduce Ruby? I got that a lot. We had Sake and we had PowerShell. And yeah, so we tried a lot. Our main problem was our deployment automation was copy-pasted between all of the applications. It was not the choice of the language of the deployment automation, it was the fact that we had 120 different versions of almost the same thing. And so, consequently, it was slightly different between applications, and so the people couldn't move between applications and go, oh, it's deployed by this. Oh, wait, no, it isn't. It's deployed by something slightly different. So, consistency is really important. In 2010, in a moment of clarity, we created a contract for the deployable artifact that CI produced. There's no rocket science here. It's a zip file. It contains the build output, as you might expect from the build automation. And it contains the deployment automation, because it wasn't separately packaged. And it contains all of the configuration for all of the countries and all of the environments that it was necessary to deploy to. So that is a immutable package that then gets promoted through the environments rather than built and deployed, built and deployed, built and deployed, oops, as is often the case if you don't make it immutable. In 2011, we discovered how to remotely execute things on a server, and we used SSH for this, because again, why would we use anything built into Windows? Oh wait, Windows didn't really have anything built in that worked well then. So yeah, we used Ruby and Rake with SSH to deploy to QA, and that allowed us to introduce, by convention, file system locations for things, but we still had a data center from hell, so we couldn't really invest to go to production, but it still sped up QA delivery. In 2012, we discovered documentation on WinRM and discovered that, joy of joys, it actually worked after a while of bleeding on it. And And so we wrote a bespoke deployment API, which we call Package Manager, or Pacman, to trigger these remote execution runs of take this package from CI and put it in these servers. That worked really well. In 2013, we threw it away because we migrated to AWS and we didn't need it anymore, and we needed something different. For a while in AWS, we were deploying manually by taking the package, putting that in S3, and then killing servers one by one to allow them to be replaced with the new package. That worked really well, but it was manual. Some people optimized that by having a secret URL where you could ping it to get the server to commit suicide, which had some pros and had some cons. I think /seppuku, yes. Oh no. I think they're only internal tools, but yes, that was an interesting code review. In 2015, we started to consolidate that per application mess of deployment automation into a single dependency, and we took the opportunity to get rid of the Ruby and replace it with PowerShell, which was a good choice. In 2015, we also invested some time in a different deployment service API called Just Deploy. So we killed off Pacman and replaced it with a different Ruby thing. And in 2016, the third iteration of the deployment service can still deploy, but now it's written in C#. So the 200 C# engineers can now have a fighting chance of understanding how it does that, which was a boon. Yes, we did. So the question, did we consider anything ready-made like Octopus Deploy or others? Chef, Puppet. Yep. So we did. So our deployment model was we have an auto-scaling group of servers, and to deploy, we would scale that up to double the size, wait for the new servers to come online with the new version, and then contract the group by half the size to the original size, and that would kill off the old servers because we'd have a termination policy of oldest first, right? So that was nice and simple and crude. You know, really literally hit it with a hammer and this works. And for 3 years, that's what we kept doing because it was simple enough that it didn't need anything more fancy. The bootstrapping was handled by CloudFormation and CFN init. CFN init is essentially config management by a different name. You define the commands and the files that it wants to do and create in a CloudFormation template that creates an auto-scaling launch configuration, which is essentially a recipe for a new server. And that worked really well and had the benefit of having no external dependencies other than the AWS service. We took the view that AWS is reasonably good at creating highly resilient, highly reliable, highly scalable services, and so we used that. We considered using Chef and Puppet, but that would have required us to either run the solo versions and would still need to kickstart that via user data or CloudFormation, so sort of half a dozen of one and half a dozen of the 6 of the other. And if we ran a server, then we would have to run a server. And it wouldn't just be one server, it would be a resilient cluster of servers. And it's a technology that would have to learn, and so we just decided not to. We didn't need to. With Octopus, we tried it out. And at the time, so 2013, 2014, it may have changed since, we found that it didn't handle the number of servers that we had very well. I think it wanted to do one server at a time, and that was the only strategy it had. I didn't do this. I don't have all of the detail here. I could be wrong. But we discarded it because it wasn't appropriate for the model of deployment that we wanted. But as I say, it probably has changed since then. No direct experience, sorry. There was a question here? Okay, so the question is, the deployment that we were doing, was it just deploying our software, or was it also deploying all of the dependencies of the software that we had? That's yeah. Yeah. So we created, let's call them muddy golden images in 2013. So a person, me, sat down and installed a Windows core server to have all of the things required to run a Windows service of our building, and all of the things required to run a website of our building, and then snapshotted both of those things. Those were the AMIs, the Amazon machine images, that we used for the next year and a half without really changing them. Periodically, we would boot them up, install Windows updates, and recapture them as images and move to use those. So it's a very manual process. In a hackathon, I introduced Ansible to basically be a build script for servers, and that's what we moved to for most of production. You have to understand that Just Eat was quite anarchic. Each team was aggressively decoupled from other teams and had quite a lot of autonomy in how it decided, or which dependencies it decided to take on. And so we didn't force everyone to get onto the new AMI, but we did make it a compelling argument because it was Windows 2012 R2 rather than Windows 2008. It was 64-bit. It had the later versions of things that we depended on. We didn't update the older AMIs, things like that. So it behooved people to get onto those quicker. And so that by creating the servers with our dependencies, we sped up the bootstrap time because we're not waiting for the .NET framework to download and install, and we're not trying to download and install a big thing from a ropey site on the internet. I mean, Microsoft.com, honestly. Our bootstrapping was therefore more reliable because there were fewer things to depend on, fewer things to go wrong, and smaller things to download to actually get up and running. Yep.
So do you think that at the moment, as a platform, Windows is mature enough to keep following this route? Do you think that it would actually be better to do something like you guys were doing at the time, like try to have like an image of the rating some stuff?
So I think just from an elapsed time deploying point of view, it makes a lot of sense to create the image with as much stuff on it as possible, so that you're doing as little as possible in deploy time. I don't think it really matters what you use to get the image. Like I said, for a year and a half, we had a thing that a person created that didn't have a changelog and wasn't in source control, but was also immutable. So we knew what was there just by inspection. It was just when things changed that we had problems, and it was a pain to change. I don't have any experience with Chef or Puppet. I have some experience with Ansible about a year and a half ago, some PowerShell, didn't use any DSC. And essentially, if you can capture what you want in a script, it doesn't matter what the script is. If that script runs, then that's what you get. The choice of the scripting engine or the config management is dealer's choice, really. I don't know if that's really answered the question. I've kind of dodged it a bit. Mm-hmm. Yep.
And usually what we do now as a company, we try to put the effort to write that support for those things ourselves.
Mm-hmm.
So given the state of the art of the Windows core, do you think that is it worth investing that effort in trying to do that?
I would say put it in the image, but for different reasons. Because if you put it in the image, it's there, and you don't have to do it at deploy time because that injects risk at deploy time. I think the maturity of, or the support of Windows within the various different config management tools is much further along than it used to be. In 2012, it was, hit and miss. It was, oh, you support Windows, wow, well done. As opposed to now, when it's kind of taken for granted that it will run and usually kind of work on Windows. Again, I feel I've dodged the question a bit, but yeah. Yeah.
So when you're talking about scaling and morning
Yep.
before peak time, you're just about content?
We're talking about all bits of the platform that need to scale. So when I left, there were about 120 different features of the platform, clusters of servers. I'm going to talk about clusters in a sec. And if the public API needed to go from 6 servers because that's the daytime use to 30 servers because that's the peak time use, then that's what happened. It wasn't we go from 6 to 30 for all of our features because that's not necessary. It's we go from where the load dictates to that we scale to. We only scale enough to handle the peak load.
Do you scale database?
No, the database was a special snowflake. So the database SQL Server, in case in point, was a mirrored setup because at the time Amazon didn't offer a multi-AZ, multi-availability zone offering for SQL Server. It does now. And we elected to have big database instances and keep them as opposed to add and remove them and differently size them through the day. Because the data, any time your server has data that has to stay there, there's an expense to, you become less agile with that server because the amount of time it takes to restore the data, if you need to restore the data because the server died, adds to the amount of risk window. So yeah, we ran with a vertically scaled database cluster. We were always incrementally snipping away at the database so that we could take data from the monolithic database into disparate data sources that could scale more independently. But that was always a work in progress. So at the time that I left, we had various different data sources for various different use cases. We had Elasticsearch, we had DynamoDB for very hot short-term data, we had SQL Server for the backing store, we had Redshift for data warehousing. It was very much more choose the data store that's appropriate for your use case rather than you only get SQL Server, make it work.
So if I understand correctly, you were deploying on the application backend. Have you ever considered using what IES, like gunk deploy?
Yes, we tried it, but we didn't really need it by the time we got round to trying it. So, yeah. So clusters. Everything at Just Eat was, well, we applied object orientation and dependency injection at the environment level, just like we did at the code level. So by this, I mean each feature of the platform, so the public API or the front-end website or the consumer API, the Windows service that pushes notifications, everything was its own CloudFormation stack that had a DNS name and a load balancer to handle routing traffic to the servers, and it had a cluster of servers and a code base to actually process that traffic. So we were really applying inversion of control to the environment by separating our traffic routing from our traffic serving, which also allowed us to redirect traffic if we needed to do something a bit more drastic about how we served it. So for example, if we needed to drastically change the infrastructure behind the public API, we could do that by repointing DNS, but keeping the old stack present in case we needed to point back. The pipeline. So how much time do you burn releasing software? At scale, it increases because you're deploying more and you have more things. You probably have more people. In 2010, 2011, this could take days because we planned and figured out and archaeologically discovered where to deploy things, and we fire-fought stuff that we forgot about or didn't uncover until later. In 2013, a deployment would be about a 30-minute progress bar to watch, but there was zero downtime because we're still serving traffic the entire time. In 2013 through 2016, the cycle time didn't really decrease, but it happened more regularly because we were making smaller changes more often. And in 2016, we reduced the deployment cycle time from around 20 minutes to about 2 minutes by, rather than chucking away servers, by instead updating the software in place. So now it's the existing running server is told, go and get a package, download it, unzip it, configure it, and run, and replace the old package. So there's no need to bootstrap a new server now. They're still bootstrapped every morning to replace them, because if you don't replace your servers, then you're more vulnerable to things like resource leaks, like memory leaks that leak over time, or disk space consumption where you're writing logs to the drive and you run out of drive. Throughout 2010 through 2016, our build agents were still handcrafted, still manually built and lovingly cared for, but they were spun up on demand and killed on demand. So again, we had an image, and Team City would spin that up, and as many as we wanted, and kill it when it wasn't in use. And only in 2016 did we do the same for our Team City agents as we had for our production servers, and the world was a better place because now a team can be more in charge of what's on the agents. We also started to separate deployment from release by using feature flags. I think we first did that in 2012 or so. Basically, the idea that you write some code behind an if block, and then if feature is turned off, then do the old thing. If new feature is turned on, then do the new thing. And that's a piece of configuration in a database somewhere that you change on the fly, and your feature goes live or rolls back without you needing to actually do a code deployment. So the environments that we had. Everyone has a test environment, right? It's just people that are particularly lucky that have a separate production environment from their test environment. So this is really about the systems and infrastructure automation that wraps and orchestrates how you get your packages from build into the servers in production, possibly through QA. It's still about minimizing the amount of uncertainty in your environments, because if you source control the definition of your environments, your CloudFormation templates, your Terraform modules, whatever, then you can parameterize them and use the same intrinsic environment template to go to QA as well as go to production. And so things are more the same. Maybe the sizes differ, but that's about it. At Just Eat, they spin up QA environments, 2 per team, about a dozen teams or so, every morning, and close them down again at night because, well, the engineers don't work at night. And so it's a cost-saving exercise. Immediately you slash the development budget for hosting by a third. This was a blessing because it proved that it's possible every day, and it was a curse because we didn't have good enough test coverage at the lowest part of that stack, the thing that everything depended on, to catch problems when they were introduced. So if a problem like that was merged and not noticed until the next morning, then most of the team's productivity is blown away for that next morning. But that's just like any software that crosses team boundaries, right? So good for DR, but test. Then we had a pipeline. So I guess this is pretty standard. You edit your code, you build your code, you test your code, you deploy your code. You might test your code after deploying, right? Yeah? No hands are rising? Okay. So the stuff that that you depend on to get to production from your text editor, things like source control servers, CI, agents, the deployment API, whatever. This has to be more available than your production environment, because otherwise you can't change your production environment when you need to. And usually if your pipeline goes down, then you probably are in a position where you need to change what's in production. That's just the way of things, I've noticed. We tended to do continuous testing in production as well. I mentioned every night during peak time between 4 and 8. We also run another 50% extra fake load against the production systems to prove that we can take it. There are 3 priorities to this. The first is we don't have a lot of developers that have operating in production experience, and so it's kind of new to be on call and for stuff to go wrong and be able to be on the hook to fix it. So having a button to turn off a third of the load in production buys them time to think. And so that allows us to train people in this better. Yes? Well, we don't. It's totally fake. Yes. So we had a special magic header that I won't repeat here because for a while you could get free food. But yeah, we had a special magic header that the system could decide whether it's a fake order or a real order, and that was used for faking away the payment processing. So we had a test harness that fake orders went to, rather than real orders going to the real payment processor. So we could test that part too. No, we stopped it at the bit that talks to the restaurant. Sorry, yes. So continuous testing in production. We had active tests like this, and also like your pingdom and your uptime robot type things. Homepage returns 200 OK. We had passive tests that basically looked at the monitoring and asked things like, is the 90th percentile response time, is that looking okay? Again, alerts are just tests in production. We had test automation before going to production as well, because everyone does, right? These days, it's the 21st century. So we tended towards workstation tests that run in process, so they could also be run in CI, that mock just at the process boundary, or as close to that as we can. And then increasingly, we had things like ncrunch or the new JetBrains thing that would run tests whenever a file changed, so that you were encouraged to not commit when you had broken unit tests. You don't not run the tests because the tests always run, if that makes sense. We had CI to keep us honest because not everyone had that. Yes. Oh, thousands, literally thousands. So the tool that we used would only run the tests that covered the code that has actually changed. So it's quite smart. There's also now an open source build tool that tries to do the same thing. It's called Bazel. It's something that Google are open sourcing. It's quite an interesting thing. Then when we deployed to QA, we tended to integration test one layer deep. So remote calls would happen from the thing under test, and then a recording proxy. So all of the remote calls would go through a proxy. The proxy would record canned responses to replay back to those tests. And we had alerts in production. Application coupling. So we learned that writing the contract before writing the code was a really good way to do development in a distributed system, because you have a fighting chance of the client team knowing what the server team is building and the server team knowing what the client team wants them to build, which tends to be important. We also learned that if you do the happy path last, so you make your new server call and it does nothing but spew gibberish back, then your client team is probably going to handle the errors a bit better than if they get a 200 OK, because they'll consider the errors that they could get. So that tended to work better when we remembered to do it. We used the Swagger format for specifying our APIs. We also started to use the unified log pattern for publishing events and consuming events to separate the publisher from the subscribers. This was a really good pattern that, it's called CQRS in other things, command query, something separation, and event sourcing. Called different things, but it's basically stuff happens and things listen to stuff. So you in both of those cases, you have strong input-output contracts, which means your thing is easier to test, and your thing is easier to operate, and your thing is easier to log, because your input and your output are very constrained. There's no particularly great choice that is a no-brainer for monitoring. We chose StatsD, Graphite, and Sarin because at the time that was probably the best choice to get going with, and I did find that bash script. We had to write our own scripts to harvest the performance counters. We had to write our own client to send the packets down a UDP to the StatsD server, but it was basically good. It was great because there was no ops involvement to a developer deciding they wanted to measure something. That was really important. We didn't want a developer to think about whether it cost too much to decide whether to measure something or not. It was very simple to measure something. Like I said, glue a string together, stick a number on the end, and shove it down a UDP. That's it. It was bad in that we had no consistency in what developers decided to call their metrics. And so it was impossible to come up with common alerts across applications and across teams, and similarly dashboards. So that meant it was harder for developers to go between different teams. And that turns into a piece of friction as you get bigger. StatsD Graphite itself was quite difficult, but not impossible to scale past a single server. Now that's much more of a solved problem. You can find any number of articles telling you how to, and they work. And on the cultural side, we didn't really, we suffered from a lack of guidance in how to create alerts in production that were good. So actionable alerts as opposed to the CPUs running hot. This one has a defined resolution. This one has any number of things that could cause it that you don't really know from the alert. Oh, the CPU's hot. Boring. I see the CPU going hot a lot of times, and it's perfectly legitimate for it to run hot. Log aggregation is now much more solved a thing. NXlog is the missing piece that we didn't have earlier. NXlog is the log shipper. It's a lovely piece of community software that is free, that is a Windows service that looks at your log lines and pumps them into Logstash. And you can inject your regexes or you can inject your JSON parsing as you please. So that started existing after we had this, so we didn't really look at it. I think they're looking at that now, but don't know. And then ElastAlert is a great tool from Yelp as an InfoSec tool, which is essentially a thing that will look at your logs and run queries to alert you to weird things happening in your logs. So it supports things like sudden spikes, so lots of 500 errors, sudden flatline, so no 200 errors, a new entry, so maybe there's a new stack trace just after you deploy, so that's a regression or a new weird thing, so roll back. Or a change. So, you know, this person usually logs in the UK, but now is in China. That's a bit weird. Has he had his account, or have they had their account hacked? And it gives you an operational response that is a tighter feedback loop than adding a metric to code would be. You still add the metric to code around that particular problem, but at least now you have an operational response to it. Cluster scheduling. This is the idea that you can run more than one application on a server. And we didn't really at Just Eat. So that meant that our servers were very underutilized. So if we can fit more on a server, then the risk is we lose more if a server goes down, but we're getting more bang for our buck. Cluster scheduling is having a thing dynamically allocate which applications run on which servers at runtime in real time. There was a talk about Nomad earlier. This is an example of that. For a Windows platform, this is still kind of witchcraft. Serverless is promising. We shipped a thing with Lambda, an API gateway, and Elasticsearch. Didn't have any servers that we maintained. So we didn't care about scaling, clustering, load balancing, patching, or maintaining steady state. We wrote our Node.js, we zipped it, we gave it to AWS, and it ran. And when it wasn't running, it didn't cost anything. One job for one Lambda was 80 times cheaper than the equivalent job would have been for the 3 servers that would have been processing that job, because we had 3 servers that were doing a similar job. Hiring is still hard. Developers that have operating in production experience are rare, so training them is a high priority. We tried to do things like make onboarding simpler by making things conventional between applications and between teams, naming things, putting things in the same places within repositories, writing runbooks for things that go wrong in production in consistent places, extracting common code to libraries and then not allowing those libraries to just die, which is the common case. Trying to train deliberately during peacetime, not operations, things are on fire time. And being upfront about the fact that when we hire engineers, they're going to be on call. It's not for everyone, but on the other hand, you learn an awful lot of new skills operating something in production. The future. I guess if it were up to me, I'd be investing time in a Windows platform, either containerizing applications or serverless computing. Yeah, those two things. Also, more tooling. So a distributed system, it's very important to know why something happened. So correlating events from one service to another and being able to trace that conversation is invaluable. But you don't realize that it's invaluable if you haven't needed to do that before. Also, chat ops, the idea of having a bot in your chat channel that you can tell to do things like show me a graph, and then everyone in the channel sees the graph that you're looking at and can draw the same conclusions you are, or scale up the public web by 6 servers. You then have a timeline in your ops channel for what happened during an incident that you can then analyze later in a post-mortem, rather than spending time recreating that. So yeah, that's it. Sorry I'm slightly over time. Any questions? Silence. Oh, wonderful. Any other questions? In that case, thank you very much. Yes, I'll be around.